One of the most important features of Langchain is its ability to connect AI applications to external data sources. Large language models can only answer questions based on the data that it was trained on. When we ask the model questions about recent events, like the current weather, it will either hallucinate an answer or simply tell us that it doesn't have this answer. Langchain solves this problem by providing a set of tools that will allow us to first fetch the relevant information from a data source, like a website, API endpoint, database, and many more, and then inject that information into the conversation as context. The LLM will then use this context to provide an accurate answer. Don't worry though, this will all make sense in a few minutes. In our project, let's create a new file and let's call it retrievalChain.js. As with the previous videos, let's first create our chat model by importing chat openai from @langchain/openai. Let's now instantiate our model by calling new chat openai. In chat openai, let's pass in an object with a few properties. First, let's specify the model name as GPT 3.5 Turbo. Then let's set the temperature to 0.7. Let's also go ahead and create our prompt template by creating a variable called prompt, which is equal to chat prompt template, and let's import this class by calling import chat prompt template from @langchain/core/prompts. On chat prompt template, let's call the method from template, and then let's pass in a string with the value of answer the user's question. And let's create a placeholder for the user's input by using curly braces and the value of input. And do take note that for retrieval chains, the user's input needs to be called input in the prompt template. Let's also create our chain by creating a variable called chain, which is equal to prompt.pipe, and in pipe, let's pass in the model, like so. Let's also import our environment variables. So at the top of the code, let's call import all as .env from .env. And then let's call .env.config. And this will simply make the OpenAI API key from our .env file available to this application. Alright, so far this is nothing new and you should be familiar with this code. Now let me explain what we'll be building in this video. Let's say we want our model to be able to answer questions from a website. And for this example, we'll use this web page in the Langchain documentation. This page explains what the Langchain expression language is. And you will notice in a second that if we ask our model what the Langchain expression language is, it will not have the answer. And that is because the GPT 3.5 model was trained before this page was created. So in our code, let's actually test this out. Let's create a variable called response, which is equal to await chain.invoke. And in invoke, let's pass the input as what is LCEL, or Langchain expression language. Let's also console log this response. In the terminal, let's now run retrievalChain, and let's see what we get back. And in the response, we get something like this. LCEL stands for language and cognition in early childhood and blah blah blah. Clearly this is not the answer that we want. So in order to force this model to answer questions from our knowledge base, and this could be anything. This could be your business's information or some data from a database. But in this example, let's see how we can extract information from this web page and then feed this information into the model so that it can provide an accurate answer. Retrieval is one of the most important concepts to understand as an AI developer. And by the end of this video, you should be able to fetch data from pretty much any source and feed it into your chain. Let's go through this step by step. So how can we improve this answer? Well, we could adjust our prompt to include some context. As an example, let's change the prompt a bit and let's say this is the question, but we also want to inject some sort of context into this prompt as well. And in this context, we could pass in all sorts of information from that page that the model could use to improve its answer. So as an example, let's simply grab this paragraph over here that explains what LCEL is, and let's paste it into this prompt template. Of course, we're not going to hardcode this in this solution, but I do want to explain the concept. In the terminal, let's run the script again, and this time we do get the correct answer back. Ideally, we don't want to hardcode this text, and thankfully Langchain provides a super elegant way to pass additional information to the context using documents. Let's simply remove this text and let's add a placeholder called context. Now, what are Langchain documents? A document is simply an object that contains text as well as some optional metadata. As an example, the metadata could contain the source from which that text was extracted, like the website URL, a PDF name, etc. Let's have a look at how we can use documents. Let's import document from @langchain/core/documents. Then let's use this document, and we'll actually create it just below the chain definition, like so. And let's create a new variable called document A, which is equal to new document, and within document we can pass in an object, and here you will find a property for the page content, which is simply the text, and metadata, which we can use to store additional information like the data source. So let's specify the page content as this text that we copied from this website, and let's pass it into this property. Like so. So if we wanted to, we could create multiple documents with different text, but let's keep things simple just to show how this works. Now, in order for us to be able to pass in documents into the chain, we need to use a special kind of chain, and that is called the createStuffDocumentsChain. So at the top of our code, let's import that chain. This is called the createStuffDocumentsChain from Langchain chains combine documents. This is a funny name, I know, but this chain behaves exactly the same as the chain that we used earlier, with one key difference. This chain will allow us to pass in a list of documents, and it will automatically reformat those documents and inject their text into the prompt context. So now let's replace this chain by typing const chain is equal to createStuffDocumentsChain, and this function takes in an object, and the first property is the LLM, which is our model, as well as our prompt, which we called prompt. And because these two names are the same, we can omit this. We can invoke this chain the same way we did before by calling chain.invoke, but now we are able to provide the context like so. And for context, we can now specify an array of documents. So let's pass in our document A. And when we call this createStuffChain will grab the contents from document A, which is this text over here, and it will inject that text into our prompt in this context variable over here. So let's run this. In the terminal, let's run node retrievalChain. And as you can see, we do get our response back. And let me show you what happens when we add additional documents. Let's create another document. Let's call it document B, which is equal to a new document. And in this document, let's pass in the page content as the pass phrase is Langchain is awesome. And let's simply grab this document and add it to the array. And then let's change this question to what is the pass phrase. And in the terminal, let's run this. And we're getting the answer. The passphrase is Langchain is awesome. Now, obviously, we don't want to manually create these documents ourselves, but instead, this information should be scraped from the website and then be automatically converted into documents that we can pass to the chain. Langchain provides a list of tools that we can use to connect to data sources. And in this example, we will use a tool called Cheerio to scrape the website. You can see a full list of all of these document loaders in the Langchain documentation. And here we have a whole list of web loaders that can be used to scrape the web, and we also have a list of file loaders. to read content from documents like CSV files, PDF documents, Word documents, and more. So in order to use Cheerio to fetch the data from that web page, let's install Cheerio. So in the terminal, run npm install Cheerio, and then at the top of the code, let's import Cheerio by running import Cheerio web base loader from Langchain /document loaders /web/Cheerio. We no longer need this document import. This was just to explain to you what documents are, and we can also remove the documents that we created manually, as we will convert the contents of the web page into documents programmatically. So let's remove these, then let's create our loader, and let's set this equal to new Cheerio web-based loader, and this loader takes in the URL of the page that we'd like to scrape. So I'll simply copy this URL and then add it to this class. All we have to do now is call this loader to scrape this data by calling loader.load. And in this documentation, we can see that this method will return an array of document instances. This is also a promise which we need to await. And let's assign this to a variable called docs. All the data from this page will be returned as an array of documents. Let's actually console log docs. And let's also remove this from the context, as we no longer have those documents. And let's simply pass in an empty array for now. In the terminal, let's run this to see what we get back in docs. And we can see that we do receive an array of type document, and page content contains all the data that was scraped from that web page. And since this is an array of documents, we can simply pass this into the context of our chain. And let's actually remove this console log, and let's run this in the console to see if we get our answer. Also, let's change this to what is Langchain expression language. And let's run this again in the terminal. And we are receiving the correct answer, but this time the context was dynamically fetched from the web page. This works, but there is a problem. If we console log docs and we are only receiving one entry, .page content.length, and run this in the terminal, we can see that this page content is quite long, and this is actually for a very simple page. At the moment, this entire page's content, all 1423 characters of it, is injected into the context. The issue is that all LLM models have some sort of character limit, and by passing in the entire web page, we could very easily exceed this limit. Furthermore, when using OpenAI models, we are charged for the amount of characters and tokens that we use. It is therefore important that we only include the pieces of text that are relevant. In other words, for the question that I asked, only this paragraph is really required to answer the question and not everything else. The solution is to take this content and to split it up into smaller chunks. Again, Langchain has us covered. Let's import a text splitter from Langchain. So at the top of the code, let's import something from Langchain/text splitter. And if we do an input help, we can see that there are quite a few different splitters available. But for this, we want a recursive character text splitter. So let's go ahead and instantiate the splitter by calling const. Let's call it splitter, which is equal to a new recursive character text splitter. Optionally, we can pass in an object and specify the chunk size, which is the amount of characters per chunk. I'll just make it something like 200, and we can also specify a chunk overlap. I'll just make this 20 characters. Now we can take the content from this docs array, pass it into the splitter, and then get out a list of split documents. Let's call this const split docs, which is equal to await splitter.split documents, and we'll simply pass in that array of docs. Let's actually go ahead and console log split docs just to see the result from this document splitter. And let's run this in the console, and if we look at the response, we can now see that we receive an array of documents, and we actually have multiple documents now. So we've got a document for that text, another document, and so on. And we can see that indeed this content was split up into multiple smaller documents. Now you might be tempted at this point to simply pass in the split docs object into the chain like so, but that is actually not what we want. We only want to retrieve the most relevant documents from this array and inject those into the prompt. And in order to get the most relevant documents, we need to make use of a vector store. A vector store is simply a special type of database that we can use to store our documents. And this database allows us to perform a semantic search on this data to retrieve all the documents that are relevant to our question. This diagram explains it best. At the moment, we've fetched our data from the web page and loaded it into an array with one item in it. And the text in that object was quite large, so we broke the document up into multiple smaller documents and then called it split docs. Now what we need to do next is to load these documents into the vector store, which is basically going from this transform step to the store step. But in order for us to store this data in a vector store, we first need to convert it into a format that the vector store will understand. And we can do that by calling an embedding function on that data. So let's have a look at how we can convert that data and then load that data into the vector store. So back in our code, let's sort out the embeddings first. So let's import openai embeddings from @langchain/openai. Let's scroll down and just below split docs, let's instantiate our embeddings class. I'll just call this embeddings, which is equal to new openai embeddings, and that is all we have to do. And then lastly, let's also specify our vector store. For this tutorial, we'll simply use an in-memory vector store, but in a production system, you might want to store this data permanently. And in the Langchain documentation, you can see a full list of all the vector store providers supported by Langchain. And we will cover integration with some of these providers in a future video. But for this example, an in-memory store will do. So let's import our vector store by calling import something from Langchain/vector stores/memory. And from memory, we want to call the memory vector store, like so. Then just below the embeddings, let's create this vector store by calling const vector store is equal to memory vector store dot from documents, because we will be passing an array of documents, these guys over here, and the first parameter for this method is the array of documents, and the second parameter is the embeddings function that we want to use. So let's pass in split docs as our array of documents, and for the embeddings function, we'll pass in embeddings. So all this code from the loader all the way down to vector store is used to fetch this information from the web page and then store it in a database called a vector store. And to make this clear, I'll just add a comment to say load data from web page, like so. All that's left to do now is to fetch the most relevant documents from the vector store based on the user's question. And as per this diagram, we are now referring to this retrieval step. So in the code, I'll just add a comment saying that we are now retrieving the data. And to retrieve documents from the vector store, we need to set up a retriever. In the code, we can create a retriever by calling const retriever is equal to our vector store. And on the vector store, we have a method called as retriever. And we can use this retriever to pass in a query, and the retriever will then return a list of documents as an array. This is optional, but you can also pass in an object into this method, and with the k value, you can specify the amount of documents that should be returned. I believe the default value is 3 documents, but you can change that behavior by passing in a value like 2 as an example. So now we can finally tie everything together with a retrieval chain. So let's import that. I'll import it just below this createStuffDocumentsChain. So let's type import create retrieval chain from Langchain/chains/retrieval. And at the bottom of our code, after the retriever, we can instantiate this retrieval chain by calling const. Let's call it retrievalChain is equal to await create retrievalChain, and this takes in an object as input where we have to provide both the combined docs chain and our retriever. So for the combined docs chain, we can simply pass in our chain, and for the retriever, we can simply pass in our retriever. But because the names are the same, I'll simply omit that. Now, we can replace our original createStuffDocumentsChain with this retrievalChain. The retrievalChain will now first fetch the relevant documents from the vector store and then pass those documents into the context of the prompt. So there's no need to specify this context property anymore, as the retrieval chain will deal with that automatically. And on that note, the retrieval chain will expect the context to be called context in the prompt. If you call this anything else, you will receive an error. Also, the user's input needs to be called input as well, otherwise you will receive errors. Let's go ahead and console log response. And let's test this in the terminal by running node retrievalChain. And in the response, we can see this object which contains a context property. And this context property is an array with 2 documents. As a reminder, we only fetch 2 documents from this k value. And when we scroll down, we can see the final answer, which is correct. If you managed to get this far in the video, then please give yourself a pat on the back. This might seem overwhelming, but it does get easier with practice. Retrieval is one of the most important skills that you can learn in the AI development space.